Okay, this is another one of those questions where it's really important to understand what the question's going on about. And if you figure that out, then the answers are pretty straightforward. So, okay, so we've got this tank. So it's got a tank of fuel, or some tank of some sort of liquid. And there's fuel pouring in. So like some sort of tap. So things are coming in. And there's kind of a hole at the bottom, and let's say that there's fuel coming out as well. So at some point, at some part of this process where the tap's open and the hole's closed, so we plug that, and so the volume of the water or the fuel in there is going up. And at other times, you open the hole and you turn off the tap, and the volume goes down. Okay, so the graph that we've got, we're told that we've got this graph of dv dt, and it looks like this. So let me sketch it out here for you again, even though we don't need that because it's already given to us in the question. So we're told that the graph goes kind of like that. And we're told this area here is called A, this area here is called B. So the important thing is, so there's the volume in this, let's call that V, goes up and down. But remember, the formula that we've been given is not the formula for volume. What we've been given is the formula for the derivative, the rate in change of the volume. So this is not showing us the volume, but it's showing us how fast the volume is changing with respect to time. Okay, so that's really important to get that, because if you think this is a graph of volume, then you're going to get the wrong answer. And anyway, it can't be a graph of volume because of you can't have a negative volume to start with. But you can have a negative rate of growth. And for the first minute, it does have negative rate of growth. So in fact, that's the first part of the question. It says, what does it mean? What happens at t equals 1? Well, at t equals 1, the volume, let me label this for you. So this is t, and this is the derivative of the function, volume function. At t equals 1, the volume is 0. Dv dt equals 0. So the change of volume is 0, which means that it must be a local min or a local max. So which one is it? Well, it's pretty straightforward that you can figure it out by logic, that if it starts off being negative, that means that fuel must be flowing out of the hole, so the volume's going down, and then at point 1, they plug the hole, and then it starts going up again, so therefore this must be a local minimum. Okay, so that must be a local min. Now, if you want to figure it out exactly, then you could differentiate that again. So there's a function t squared take 1. The second derivative is 2t, and at t equals 1, that's equal to 2, which is greater than 0. Therefore, it's a minimum. Okay, so that's the other way of doing it using calculus. But you can just do it by just using plain logic. Okay, so what does that mean? So explain what happens at t equals 1. Well, at t equals 1, the local minimum, so the volume, let me write this out, at t equals 1, the volume is a local min. Okay, so that's the first part. Okay, the second part is saying find the area of region A. So A is this region here from 0 to 1. So it's the integral of the function from 0 to 1 of that derivative, dt. Okay, this is a calculator section, so you can't put the numbers in there, but into calculator and figure it out. But actually, this is easy enough to differentiate. So derivative, so the integrate, so integral of t squared is 1/3 t cubed. Integral of minus 1 is t, and we're doing it from 0 to 1. So when you put 0 in, you get zeros, and this one is going to give us minus 2/3. So is that right? So it's a negative number, and that is right. It's below the x-axis, so the area is a negative number. So actually the area of A is actually 2/3. Okay, 2/3 of a liter. And interpret the answer. So what it means is that A, so from 0 to 1, it means that this volume, the fuel is flowing out. Okay, so in the first minute, it's 2/3 of a liter of fuel flowing out in our first minute. Okay, now So the next part of the question asks you to do the same thing for b. So this is a pretty straightforward thing, exactly the same as what we did before, except this time instead of going from 0 to 1, we're going from 1 to 2. So the integral from 1 to 2 of t squared take 1 dt. Same process, 1/3 t cubed take t. This time we're going from 1 to 2. So let's do the calculations. So what do we get? That's 1/3 there. So 8/3, which is t squared t cubed, minus t, which is 3. Sorry, 2. We're going from 2 there. Subtract 1/3 plus 1. So what have we got? 8/3 minus 6/3 is 2/3, minus 1/3 is 1/3, plus 3/3 is 4/3. Okay, so 4/3, what is it? Liters. Okay, and what does that mean? From 1 to 2, that means fuel flowing in. So, in second minute. Okay, all right. So let's continue. So the last part of the question. So part D says, find the amount of fuel in the tank after 2 minutes. If initially there were 5 liters, and it's pretty easy, right? So the amount of fuel in the tank after 2 minutes. So we started off with 5 liters. In the first minute, we lost 2/3 of a liter, which is what this says here. And in the second minute, we gained 4/3 of a liter. Okay, so that's 15/3 minus 2 is 13/3, plus 4/3 is 17/3. So that's 17/3 of a liter. So the amount of fuel in the tank, that's the answer. And the last part says, okay, so find the average rate of change. So average is always just figure out the total and divide by the time. So the average is at 17/3. Subtract the initial value, which is 5, and then divide by the time, which was 2 minutes. So what's that? 17/3 minus 15/3 is 2/3. Divide by 2 is 1/3. 1/3 liters per minute.